Welcome. In this lecture, I'm going to go through an example of the inverse of a function, and in some sense, this is like almost a schematic example. It's not exactly the kind of example you're likely to see, except that in a lot of ways, that's actually the most useful because it's going to allow you to kind of really see how the correspondences work. So here we go. So if we're going to have f, which is going to go, so it's going to go from the set, which is going to be, it's just going to contain 1, 2, and 3. And then we're going to map to the set, which contains red, yellow, and blue. Okay. And it's going to be defined by so what's going to happen is we're going to have, so we're going to say f of 1 is going to equal blue. So maybe I'll actually kind of write each of these like this so I can just do them all at the same time. Okay, so we're going to look at what's the image of 1, 2, and 3. So these are going to equal blue, red, and yellow in that order. So we have blue, red, and yellow. So what that's going to look like is we have here, we have 1, 2, and 3. And over here we have, so 1 point, I put them in a different order on purpose, red, yellow, and blue. And then, so this tells me 1 goes to blue. So we have 1 goes to blue. And then we have 2 goes to red. And then we have 3 goes to yellow. Okay. It's a nice bijection. How do we know? Because everything, right, it's surjective. Everything over here is hit. Nothing's left kind of alone there. It's injective because no two inputs go to the same output, right? We don't ever see 2 arrows going in there. Okay, and now, so it has an inverse. So what would the inverse look like? So F inverse, and what is this going to do? So this is going to take red, yellow, blue. And we're going to go to 1, 2, 3. Okay, and so now, we're going to need to figure out where our F inverses go. So this is going to be defined by, so we've got to say where red goes, and where yellow goes, and where blue goes. We need to say where each of these goes, or the function's not well defined, right? And it has to be something that lands in here. But we know, right, so how do we figure it out? So we look at red as an output and we look for what its input was. We look for yellow as an output, we look for what its input was. We look for blue as an output, we look at what its input was, like this. Okay, so then we have, this now goes the opposite way, right? So it's going to be, we could actually, you could draw it the opposite way and just turn your arrows around. Let me actually do that. I like that. So we have red, yellow, and blue. And then it's going to get mapped to 1, 2, 3. And we're just turning our arrows around, right? So red has got to go to 2. And yellow's got to go to 3. Okay, so these are I've just turned those 2 arrows around, and then blue has to go to, they look more parallel here, it's just kind of how I oriented it, and blue needs to go to 1, right? It's the same picture. I have the 2 parallel ones, and then I have the one that goes all the way across like that. Okay, so you can kind of see, hopefully this example is, and sometimes this is helpful because it allows you to see how you can have how the pictures actually just really exactly undo each other, and also to think through, well, what does it really mean to kind of trace back through as to define the inverse. Okay, so hope that was helpful, and I will see you in the next lecture.